is the continuation of the same chapter. The second concept what we are going to discuss is the properties of EM waves. Properties of EM waves. This is very important one in exam point of view, even for MCQ exams also. Yes, the first property what we are going to list is the source of the electromagnetic waves are nothing but accelerated charges, or simply you can say that accelerating charges. Whenever charges gets accelerated, then it can produce the electromagnetic radiations. That is the source of electromagnetic waves are accelerating charges. The second one, children, the nature, since we are telling that has to be a wave, so what type of wave it will be means it is a transverse wave. It is what, children? Transverse wave. We know that in in waves lesson in 11th standard we may study that transverse means what, children? The vibrations of the particles are perpendicular to the direction of propagation. But here the oscillation of the electric and magnetic field, that's why it is called electromagnetic waves. So the electric field and the magnetic fields are perpendicular with each other, and also perpendicular to the these two are mutually perpendicular, also all together is perpendicular to the direction of propagation. What, children? Direction of propagation. Yes, this is the another important one. So direction of propagation, direction of travel. So for example, you just consider that there is a coordinate, say for example x, y and z. Suppose the variation of the electric field is shown along the x direction, and along y is magnetic field, and that along z is what, children? Direction of propagation. And most of the cases we can assume that the variation of the electric field and magnetic field is a sinusoidal or periodic function. The simple one what we can call it as is children, a sine function. Yes, it will be like this, for example. So along the y direction what we said, the magnetic field is varying. So similarly you just see that the electric field is varying along the x direction. That also can be shown like this. Yes, children, yes, you know the basics of plane progressive waves in waves or lesson, yes, in 11th standard. So this is the variation of electric field. Okay, but you just see that diagram. Yes, whenever magnetic field is positive maximum, at the same time electric field also positive maximum. That means we can say that the maxima and minima, when magnetic field is 0, electric field also 0. Therefore the maxima and minima reached by the electric and magnetic field values are same. That means we can say that there is no phase difference. There is no what, children? Phase difference between the electric and magnetic field in the electromagnetic waves, or we can simply say that electric and magnetic fields are in phase with each other. That is the important point we must know. So what is that important point, children? Yes, electric field and the magnetic fields are in phase with each other. That means there is no phase difference. That means what, children? There is no phase difference. That means whenever the magnetic field is positive maximum, electric field also positive maximum. Whenever magnetic field is negative maximum, electric field also negative maximum. In that manner we should consider, since they are in phase with each other, and that direction of propagation is perpendicular to the both electric and magnetic field, because it is in plane board it is difficult to draw the three-dimensional image, but you can easily understand. Yes. And the second property is over. Is what is that second property, children? Transverse wave. Electric and magnetic fields are perpendicular with each other, and the two are perpendicular to the direction of propagation. And another important thing what we must consider is mechanical wave means we know that the material medium is necessary for wave propagation. But here, since it is electromagnetic wave, Maxwell suggests that no material medium is needed. No need of medium. No need of no medium is not required. Medium is not required for the propagation of the electromagnetic waves. That is the important point we must know. And the third point, as here itself I said that electric and magnetic fields are in phase with each other. That means they will reach maxima and minima simultaneously. So now I will go for the a third property. Yes, children, what is the third property means? Yes, the plane wave equation. The plane wave equation, what we are going to write. So as per this diagram, we assume that along the x direction electric field is changing. Therefore I can say that is a plane wave equation is a plane progressive wave, or simply I can call it as plane wave equation. Yes, what is this plane wave equation, children? We know that along the x direction I am assuming that electric field is changing. Therefore I can say that Ex equal to E naught sine of omega t plus or minus kz. Yes, similarly along the y direction magnetic field is changing. So therefore By, yes children, so that is equal to B naught sine of omega t plus or minus kz. In the AC chapter we said that what is the phase factor and amplitude. So before this trigonometric function, what is that? That is called amplitude of the electric field. And after the trigonometric function, what is that? That is called a phase factor. In order to give the general explanation, I have used plus or minus symbol here. This plus or minus either is in front of the k or in front of the omega. That is, omega means angular frequency, k is called a wave number. But anyway, whether if the inside the bracket, you just check whether the positive sign is there or negative sign is there. The first thing. And second thing is, the next to the wave number k, check the coordinate. As per this diagram, we said that wave is traveling along the positive z direction. Positive what, children? Z direction. So from this plane wave equation, is the following results we must keep in mind. The first one is, check the coordinate. Check the coordinate next to k value, next to wave number, next to, that is next to this is next to k, that the k is called wave number. K is called what, children? Wave number. Yes, check the coordinate. Here what we said, z is there. What z represents means the wave is traveling along z direction. Whether it is positive z or negative z, you just check the sign of the term involved in this. You try to understand, children, this plus or minus or the same can be written like this also. Suppose I am writing the same thing as to be like this, kz plus or minus omega t. Both the results are same, will give the same information, so we no need to worry about that. So now please see that for the understanding purpose I have given plus or minus, but as per this diagram our wave is going along plus z direction. You just see that first point is check the coordinate next to the k. Yes, that will gives the, yes, which gives the direction of wave propagation. Direction of, yes, wave propagation. Direction of what, children? Wave propagation. First point. Yes. The second thing is, in what direction it will go? Along the positive positive coordinate or yes, negative coordinate, means you just check the sign. Suppose the sign will be positive. The sign will be positive means your wave is going along. Yes, negative. What coordinate is there, children? Yes, negative of the yes coordinate. Negative of the coordinate. Suppose the negative sign only is given. Suppose the negative sign only is given. You try to understand, children. Suppose the negative sign alone given in the as a phase factor term, then we can say that your wave is traveling along positive of the coordinate. Positive of the coordinate which present next to this wave number k. But as per this diagram, what is the answers or means? I can say that since our wave is going along plus z direction, and your electric field is varying along x direction and magnetic field is varying along y direction, for this diagram I can write this equation, children. Is yeah, so we can write that for this diagram the wave equation, the plane wave equation can be written as Ex equal to E naught sine of is what, children? Omega t, since it is going along plus z direction. Positive of the coordinate means what, children? Negative sign should be there. So therefore minus kz. This kz omega t minus kz or kz minus omega t, both are same, which will give the same s information only. So similarly we can write that by, that is equal to b naught sine of, since we said that there is no phase difference between electric and magnetic field, so whatever the phase factor is there for yes electric field will be same as to be for yes a magnetic field also. Therefore I can write that this has to be what, children? Omega t minus kz for this diagram. Yes, that is the information for the plane wave equation. The another important results what we must consider here is the omega is called angular frequency s, that is given by 2 pi f. Angular frequency what, children? 2 pi f. Yes, this is the angular frequency. This is angular frequency. This is frequency of the electromagnetic waves. Some books they may use or we can write that omega has to be 2 pi nu also. That anyway this nu represents frequency. If you are not familiar with this, you can go with the f frequency. The another term what we said, children, k, wave number. Yes, so wave number is wave number. Yes, everything we are already discussed in waves lesson. So k is equal to what, children? 2 pi by lambda. K is equal to what, children? 2 pi by lambda. Yes, all these omega and k are positive constants. So when you are taking the value, it is not minus k. Since as we said omega and k are positive constant, whether it is for negative sign is there or positive sign is there, it doesn't matter. When the omega value is taken or k value is taken, it should be taken only the magnitude, because omega and k are what, children? Positive constants. So where s omega and k are positive constants for the yes a given wave, given electromagnetic wave, children. Yes, that is the thing you must keep in mind. And another one, yes, the fourth point what we are going to discuss is yes the fourth property is velocity or speed. Velocity or what, children? Speed of the electromagnetic wave. Velocity or speed of the electromagnetic wave. Now you please see that yes any wave can be, yes velocity can be written as to be frequency into wavelength. Therefore the first formula what I am going to give is c is equal to f lambda or nu lambda, or we can write that as to be nu lambda. The another formula is what we can give is c is equal to omega by k. C is equal to what, children? Omega by k. As since we are already discussed what is velocity selector in chapter 4, magnetic effect of electric current, Lorentz-Force concept. There we said that velocity selector formula V is equal to E by B. So similarly I can write that C is equal to what, children? Is E naught by is B naught. C is equal to what, children? E naught by B naught. Okay, yes. Yes, these are the formulas related to the constants of the S value, and another formula will be there which relates the property of the medium, which relates the what, children? Property of the medium, that is C is equal to 1 by root of mu naught epsilon naught. Permeability in free space, permittivity in free space, that we know that. This is in, we know that the value of is the speed of light in air or vacuum, that the value is C equal to 3 into 10 to the power of 8 is what, children? Meter per second. Suppose the same electromagnetic wave is traveling through the material medium, then that time I can write that V medium, velocity in medium, that can be written as 1 by root of mu into epsilon. That is permeability of the medium and permittivity of the medium. But we know that as 1 by root over this mu is nothing but mu naught mu r. Similarly epsilon can be written as epsilon naught epsilon r. So therefore I can rearrange the term. Therefore V medium is equal to, the same can be written as 1 by root of mu naught epsilon naught into root of mu r epsilon r. But you know that 1 by root of mu naught epsilon naught is nothing but c. Therefore I can say that V medium, that is velocity of the electromagnetic waves in medium, that is given by this term is nothing but c. Therefore I can get that c divided by root over is mu r in what, children? Epsilon r. Yes, this is the another result. And also we know that from the optics, you may studied or we may discussed in ray optics, the absolute refractive index, of the medium, refractive index of the medium is n is equal to what, children? C by Vm. C by what, children? Vm. So just to find the C by Vm, then what you will get, children? That is equal to root of mu or epsilon r. So these are the information related to velocity or speed of the electromagnetic wave. Yes, children. Yes, so please keep that one in mind. And another one. So another one is fifth property. What is the fifth one? What we are going to discuss or means, just see that general definition for intensity. Or before going to that, we will discuss the energy of the EM wave. Energy of the EM wave. This is very important one. Energy of the EM waves. You just see that, children. In a capacitance topic, we studied that the energy density, energy per unit volume stored by the capacitor is given by UE, that is equal to what, children? Of epsilon naught ERMS square. What is RMS value? That and all we already learnt in AC lesson. And similarly, the energy stored in the inductor, that means the magnetostatic energy. This is called energy density, energy by volume. So density, energy density. What, children? Energy density. In electric field, it is given by half epsilon naught. This is RMS value of electric field, ERMS square. Similarly, I can write that energy density for the magnetic field, that is BRMS square divided by 2 mu naught. Yes, these derivations or concepts we are already discussed in capacitance topic as well as inductor topic. Okay, children. Yes. Now please see that energy density, I can call it as energy density, energy per unit volume. Energy density means what, children? Energy per unit volume. Therefore, for electric field, the energy corresponding to electric field is given by what, children? As we said earlier, energy density, that is equal to energy by volume. That is, I can write that energy by volume, electrostatic energy by volume, that is equal to what, children? UE. That the suffix E represents electric field. Okay, so that is of epsilon naught ERMS square. But we know that RMS value is nothing but E naught by root 2. So the square of that value is nothing but E naught square by 2. Therefore, I can get that as 1 by 4 epsilon naught E naught square, where E naught is amplitude of the electric field. But we know that by the definition, we know that generally RMS value is nothing but peak value by root 2. Peak value by what, children? Root 2. Similarly, for magnetic field also we can write that BRMS equal to B naught by root 2. Yes. So similarly, for magnetic field, we can write that UB, that is equal to this is energy density, small UB. So volume, that is equal to what, children? BRMS square divided by 2 mu naught. Just you substitute the value of BRMS. BRMS equal to what, children? B naught by root 2. B naught means amplitude of the magnetic field equations, what we have written there. Therefore, we can write that as B naught square divided by 4 mu naught. B naught square divided by what, children? 4 mu naught. Yes, please kindly note down the concept, students. Continuation of that energy density, what we discussed as a fifth property, we know that energy density corresponding to electric field is 1 by 2 ERMS square is epsilon naught, that is equal to what, children? ERMS is nothing but E naught by root 2, that whole square we can write that is 1 by 4 epsilon naught E naught square, amplitude of the electric field. So similarly for magnetic field, energy density can be written as 1 by 2 B RMS square divided by mu naught, or same as to be written as to be 1 by 4 is B naught square divided by is mu naught. Yes. So what is the average energy density? So therefore the average energy density of the EM waves, average energy density of the EM waves can be written as U average, that is nothing but U electric field plus U magnetic field. That means what, children? Energy density corresponding to electric field and magnetic field. So it just I can take this results directly. Therefore 1 by 4 epsilon naught E naught square plus 1 by 4 B naught square divided by what, children? Mu naught. Yes, this is the U average equation. Yes. Now we please see that, children, by using the so just we know that C is equal to what, children? 1 by root of mu naught epsilon naught, and you just see that speed of light is nothing but E naught by B naught. Okay. So just use these two relations and substitute this equation. So now you please see that I can write that this has to be C square, that is equal to 1 by mu naught epsilon naught. Yes. So just see that is equal to, this is equal to C square is nothing but what? E naught square by B naught square. E naught square by what, children? B naught square. So from this I can say that B naught square is equal to, so therefore I can say that B naught square, that is equal to what, children? Mu naught epsilon naught E naught square. B naught square equal to what? Just cross multiply this. So take this result and substitute as in this equation. Just replace B naught square. Therefore I can say that U average, that is equal to what, children? Is 1 by 4 epsilon naught E naught square plus 1 by 4 mu naught is there. So 1 by 4 mu naught. B naught square is what, children? Is mu naught epsilon naught E naught square. So this gets cancelled out. 1 by 4 epsilon naught E naught square, 1 by 4 epsilon naught E naught square. So it will come, that has to be U average, that is equal to epsilon naught square E naught square by 2. As the average is energy density in terms of electric field. Similarly, you can write from this, we can write that E naught square equal to what, children? B naught square divided by mu naught epsilon naught, and replace this E naught, then we can get it is same as to be B naught square divided by 2 mu naught. This is the average energy density corresponding to the electromagnetic wave. And another important property is the total energy of EM wave. The total is energy. The total energy of EM waves are equally distributed, or equally is distributed between what, children? Electric and magnetic field. Yes. And another point what I can say this, all the optical phenomenon, optical property is depends only on electric field, because the magnetic field value will be very less. Therefore all the optical phenomena like polarization and other factors or phenomenons are depends on electric field. So this is the fifth property what we discuss. The next property what we are going to discuss is energy. And we know that energy, here it is represented as U. So energy is nothing but what, children? Yes, you just see that energy density means what? Energy by volume. From this energy equal to what, children? Therefore I can say that U is nothing but, please remember, energy density means U is equal to A small u is equal to capital U by volume. From this, u is equal to small u, energy density into volume. Therefore, I can write that u into S volume. U into what, children? Volume. Yes, this u is here I am taking, that has to be average energy density. What, children? Average energy density. So please keep that one in mind. So energy of the wave, that is equal to u average into volume. Okay, children. Yes. The next one what we are going to discuss is called intensity. Generally we are already studied even in thermal properties also. Generally intensity means what, children? Energy per unit area in unit time. Therefore energy per unit area, energy per the intensity of the electromagnetic wave or radiation, energy by area into time. Area into what, children? Time. We know that already energy by time is nothing but power. Yes. So or we can say that this is power by area. This is what, children? Power by area. Yes. The same expression can be rewritten here. Therefore I can write that I is equal to, yes, children. So I is equal to what? Energy by area into time. So energy value is there here. Therefore I can write that energy is nothing but energy, average energy density into volume. So the energy can be replaced by this. Therefore I is equal to what, children? U average into volume divided by, what is the formula here? Area into time is there. Therefore area into what, children? Time. That is equal to U average. These are the very important area where the students may get some confusion. That's why I am going a slow and a very deep explanation for your understanding purpose. Volume can be written as what, children? Area into distance. Say for example that is some x dx distance the wave is traveled. Okay, and divided by, you just see that area into time. Yes. So this area gets cancelled out. Distance by time is nothing but velocity. Here we are talking about electromagnetic waves. Therefore I can say that I is equal to what, children? U average into speed of light. I is equal to what, children? U average into speed of light. Average energy density formula is already given there. Yes, you can remember this. Okay. Yes, children. The another one what we are going to write is poynting vector. Poynting is vector. Since we know that the poynting vector will give the information about in what direction the energy is transferred. That means we can say that, in other words, we can say that the direction of wave propagation. The poynting vector may give the information about the direction of wave propagation or in direction of energy transfer. So that is generally given by S vector. Therefore the poynting vector is given by S vector equal to E cross B vector divided by S mu naught. But we know that B by mu naught is nothing but magnetic field intensity H. Therefore we can say that E vector cross what, children? H vector. Okay. So the S vector gives the information about energy transfer, the direction of energy transfer or the direction of wave propagation. Okay, children. Yes, the another one is you just see that energy of the EM waves. So far we discussed in wave picture. Suppose energy of the wave is wave electromagnetic radiation in photon picture, because I can give this one for our understanding purpose. Energy is in terms of particle nature. In terms of particle nature, that is nothing but photon. That is nothing but what, children? Photon. As suggested by Max Planck, I can say that energy of the single photon, say for example U, each energy of the single photon. So energy of the one photon. One photon. I can say that U each, that is equal to what, children? H nu or HF frequency, or that can be written as Hc by lambda. Yes. So therefore there are n number of photons are there. So for n number of photons, for n number of photons, we can say that is the total energy. So U total, or I can simply say that U, that is equal to what, children? N into U each. N into what, children? U each. So that is the a total energy, that is number of photons into energy of the single photon. Okay, children. So this is the information about energy of the electromagnetic radiation in terms of particle nature. So this point is given here for the understanding purpose of the concept. Yes, children, please note down the theory. Continuation of that is the another property what we are going to discuss is the another property, that is nothing but momentum. Momentum is carried by the we can call it as, that is a small p, momentum carried by the electromagnetic radiation. As we know that from the Einstein's equation, Einstein's relativistic equation for energy, it is given by E is equal to energy, but here we are taken that has to be U as a energy symbol here, that is equal to root of P square C square. This is momentum, P square C square plus m naught square C power 4. But the rest mass of the photon, that is considered to be 0, because the rest mass of the photon will be 0. Therefore we can say that the energy of the electromagnetic wave or radiation is that is equal to P into C. That is equal to what, children? P into C, the general expression. Okay. So therefore the momentum of the electromagnetic radiation for the two different surfaces. One may be the reflecting surface, one is absorbing surface, and another one is what, children? Reflecting surface. Another one is what, children? Reflecting surface. Here only one photon is there. So this is the only one incident photon. This is the absorbing surface. Absorbing what, children? Surface. So in this case, we can write that momentum P is equal to U by C. Momentum P is equal to what, children? U by C, where U is total energy. U is what, children? Is a total energy. Total energy. Okay. Yes. But in the case of we just see that in the case of reflecting surface, you just see that this is the incident photon and this will be the reflecting photon, a reflected photon. In this case, we can say that this is the reflecting surface. Reflecting is a surface. In this case, two photons are there in the system. Therefore, P is equal to 2 times of U by C. 2 times of U by what, children? C in the case of what, children? Reflecting surface. In the case of what, children? Reflecting surface. You please kindly keep that one in mind. The another one what we are going to discuss is momentum. We discuss the next one property what we are going to discuss is radiation pressure. What, children? Radiation is pressure. So what is the radiation pressure? Means whenever the momentum is there, whenever momentum is transferred to a particular area, then there will be force by area. We can define that as to be radiation pressure. So this is given by capital P. Please be careful with the symbols. Therefore, I can give that radiation pressure for two different surfaces. One is for absorbing surface and another one is what, children? Is a reflecting surface. Reflecting surface. Yes. For the absorbing surface, the radiation pressure is given by capital P is equal to I by C, where I is called intensity. Where I is called what, children? Intensity. In the case of a reflecting surface, P is given by 2I by C. P is equal to what, children? 2I by C. Yes. Yes. And general definition for pressure is nothing but force by area. So if you want to find out the radiation force, then we can write that F by A has to be. So this is same as to be is F by A. So from this we can say that the force exerted by the incident electromagnetic radiation or photon on the surface, absorbing surface, which is given by F is equal to what, children? Is IA by C. And similarly here also we can say that the force acts on the reflecting surface is given by this one for absorbing surface. For reflecting surface we can give this has to be F by A. Therefore we can say that F is equal to what, children? Is 2IA divided by C. Okay. So these are the important properties of the electromagnetic radiations or electromagnetic wave. In exam point of view, displacement current is very, very important, and calculation is numerical point of view. And this property of electromagnetic wave is very, very, very important for numerical point of view. Okay, children. So you please kindly note down the theory, students.